Now, substitution is not the only way of solving a system of equations. What you can do here is you can actually manipulate entire equations altogether to ensure that when you add and subtract them, terms will cancel out. So how you would go about doing this secondary method is, if you take a look at these two equations, let's say we wanted to, for a change, just solve for x. That means we're going to want to get rid of the terms that have y in it. So if you take a look at these two equations, there are two terms that have y in it. One is positive 4y, and the other is negative 8y. So what you can do here is you can actually scale the top equation by a multiplication by 2, so that when it is added to the bottom equation, the y terms will cancel. So how you would do this is it's a little more intuitive as opposed to rigorous, but if we take this top equation and we multiply everything by 2, we'll get 10x plus 8y is equal to 20. Right? These two equations, these two top ones, the one we just made and the one we started with, they're actually the same because you can always manipulate equations by multiplying by whatever numbers you want, so long as you've done the same thing to both sides equally. Now, if we take a look at the second equation here, we can bring it over and line it up. Now, what you'll notice is these two equations, if we were to add the left-hand sides together, the y terms would cancel because one has positive 8y, the other has negative 8y. We're actually fine to do this because at the end of the day, for both these equations, the left and right-hand sides are the same. If we add the two left-hand sides together and we add the two right-hand sides together, we typically speaking have not changed this equation in the slightest. So to accomplish this, we can add 10x and 6x together, which gives us 16x. 8y minus 8y is going to give us 0, so I'm not even going to write anything here. And 20 plus 8 will give us 28. This allows us to solve for x very quickly. All we need to do is take 28 and divide it by 16. And this will give us 1.75. Just like we got with the previous result. We can again take this, put it in either of our equations. So let's use the other one. We know that x is 1.75. And our goal would be to solve for y in this case. So we can do this. 6 times 1.75 is a number. It's just 10.5. We can rearrange and solve this. We can add 10.5, or sorry, we can subtract 10.5 from both sides. And then we can divide by negative 8. And so if you work your way through, you will get the exact same thing that we got using the previous methodology. However, what you will notice is this is significantly faster. The only issue with this particular method is right at the start here. In order to utilize this method, you have to be able to look at the equations that you've been given and figure out how to manipulate them so that when you add or even subtract the equations together, the terms that you have in it, at least one pair of them, will cancel out.